In this lesson, I'll give you an overview of our chapter on data storage, including SQLite databases. On the storage options page of the developer's website shown here, 5 options for data storage are listed: shared preferences, internal storage, external storage, SQLite databases, and network connection. Which option you choose depends on your specific needs, such as whether the data should be private to your application or accessible to other applications, how much space your data requires, and the level of complexity of your data structure. In the lessons of this chapter, we'll look at the code to implement the first 4 of these options. Network connections will be addressed in a separate chapter on connectivity and remote access. We've already looked at preferences in our lessons on settings and preferences. Preferences can be used to save and retrieve key-value pairs of primitive data types such as strings and integers. You wouldn't want to use preferences for large or complex data structures, but it's a convenient and easy way to handle smaller, simpler collections of data. Internal storage refers to files saved directly on the device's built-in memory. By default, files saved to internal storage are private to your application and can't be accessed by other applications. When the user uninstalls your application, these files are removed. External storage refers to removable storage media like an SD card. Files saved to external storage are usable by other apps, and they can be modified by the user when the user uses a USB link to transfer files onto a computer. Database refers to SQLite databases, and these are used for data structured in a table-like format where you have different fields for each entry, and you want to add, change, or retrieve data based on field values. Databases can be accessed from within your application, but not from outside it. The network connection option refers to accessing data on the internet that's usually stored on a server. And this might be anything from small sets of data to huge databases. And as I said, we'll cover using networks in another chapter. That's our overview of the data storage chapter. Well, let's move on to the next lesson and look at some code. In this lesson, you'll learn how to use shared preferences to store and retrieve data. Shared preferences are a convenient and easy way to handle smaller, simpler collections of data. Preferences can be used to save and retrieve key-value pairs of primitive data types, such as strings and integers. For example, you might use shared preferences to store a location that a user has entered into your app as a criteria for searching for places like restaurants. Say they entered San Jose, California. You'd store the string San Jose, CA in shared preferences under the ID location, and it would remain there until the user changed it or uninstalled the app. The web page shown here is the Shared Preferences section of the Storage Options page on the developer's website. It has a good, concise explanation of how to use shared preferences. We'll come back to it in a moment. In the API Demos worksheet, there's a primary group of preference entries in lines 161 through 169. We've already looked at shared preferences in our lessons on settings and preferences, so you might want to review those lessons as a background for this lesson. Let's take a quick look at the Preferences from Code demo. We'll start the API Demos app, click on Preference, and Preferences from Code. And then we'll click on Edit Text Preference. This has an instruction of enter your favorite animal. So I'll enter dog. Now if I close the API Demo app and then re-enter it and click on Edit Text Preference, you see our data is still there. It's been saved in shared preferences, and it'll remain there unless I uninstall the app. Now let's look at how you can change a preference's value using Java code. In the Storage Options page on the developer's website, click on Using Shared Preferences, and then let's scroll down and look at this section of sample code. It's basically a 2-phase process. In the onCreate method of your app, you access the data stored in your preferences. you use it and possibly change those values. In the onStop or onPause methods, you save your values. Let's take a look at the first phase, accessing your data. This is demonstrated in the code lines with the comment line, Restore Preferences. First, you create a shared preferences object called settings here using the getSharedPreferences method that specifies your preference name. Next, you use the appropriate get method to retrieve a value from preferences based on an ID, which is silent mode in this example. The second parameter, false in this case, specifies a default value if no value in your preferences was found. Now let's take a look at the different get methods you can use. We'll scroll up and click on this link to the Shared Preferences class. And then we'll scroll down to the methods, and you see them listed here. Get all, get boolean, get float, get integer, get long, string, string set. Which one of these methods you use depends on the type of data you're storing in your preferences. Now let's go back to the previous page and scroll back down to the code. After we've retrieved a value, silent in this case, we can use it in our code to take an action, such as using it in the setSilent method. Now let's look at the second phase, saving our preference values. In this case, we're doing it in the onStop method. The first statement creates a shared preferences object, just like we did above. The second statement creates a shared preferences editor that we'll use in the next statement. In that statement, we use the appropriate put method to store our value, the preference identified by the ID, silent mode in this case. Finally, we have to use the commit method to make the changes permanent. That's our lesson on using shared preferences to store and access data. It's a really straightforward and convenient way to store simple and smaller sets of data. In this lesson, you'll learn how to access and use internal storage from your Android apps. And these are files stored in the device's built-in memory. And we're going to look at the code to do this in an API demo. In the API demos worksheet in line 91, there's a demo read asset in the content primary group, assets secondary group. It has a Java file name of read asset. So let's fire it up in the emulator. We'll click on Content, Assets, and Read Asset. And we see the text that explains that the text was read from a raw asset and placed in a text view. So let's open the code in Eclipse. In the Content Source folder, we'll open Read Asset. And line 34 defines our read asset activity. Line 43 uses the setContentView method with the read asset layout to initialize our display. So let's take a look at that layout. It's a simple linear layout with a text view that has an ID of text, and that holds the text that we read from our file and displays it on our screen. Back in our Java source, line 48 defines a try method that's coupled with the catch method in line 67 to detect file errors. Line 49 creates an input stream object using the open and getAssets methods. And getAssets returns an asset manager which provides access to an application's raw asset files. And this uses a lower-level API that allows you to open and read raw files that have been bundled with your application. And the open method uses the file name readasset.txt. So if we look in the assets folder, we see our readasset.txt file. Back in the source code, line 54 uses the available method to determine the size of the estimated number of bytes that can be read or skipped without blocking for more input. Line 57 creates a buffer for the data using the size variable. Line 58 reads the data into the buffer. Now, for larger files, this read process might need to be more complex, reading through multiple blocks until the end of the data is reached. This is just a simple example of reading a small file. 59 closes the file. Line 65 retrieves the text view from the layout. Line 66 places the text we read into that field in the layout. So that's an example of reading an internal file. To see the code to write an internal file, go to the Storage Options page on the developer's website, shown here. And here, it shows a simple few lines of code to write a file. The first line uses the File Output Stream class to create a File Output Stream object and open the file using the Open File Output method. The second line uses the write method to write the file. The getBytes method retrieves the bytes to be written. The third line closes the file. And there's some additional useful detail also included on the web page. So that's our lesson on internal files. Let's move on to see how to handle external files. In this first of two lessons, you'll learn how to access external storage from your Android apps. In this first lesson, we'll look at a number of setup functions. In the second lesson, we'll look at how to create and delete these files. Every Android-compatible device supports a shared external storage that you can use to save files. This can be removable storage media such as an SD card or non-removable storage inside the mobile device. Files saved to external storage are world-readable and can be modified by the user when they enable USB mass storage to transfer files to a computer. We're going to look at code to do this in an API demo. In the API demos worksheet in line 100, there's a demo external storage in the content primary group under the storage secondary group. So let's fire it up in the emulator. We'll click Content, Storage, External Storage. And we see three sets of buttons. The top set creates a public picture, the middle a private picture, and the bottom a private file. When you click the Create button, it creates the file, and the Delete button deletes it. Now this will make more sense as we get into the code, so let's do it. In the Content Source folder, we'll open External Storage. And line 49 declares our external storage activity. Line 50 declares a layout variable for a screen display. 52 through 55 define a class for the layout for each group of items in each row of our layout. 58 through 60 declare 3 items, 1 for each row. 63 through 119 define our onCreate method. Line 66 uses the setContentView to initialize our display using the external storage layout. So if we open that, lines 17 to 20 define a scroll view, and lines 22 through 26 define a linear layout within the scroll view, and it has an ID of layout. Back in our source, line 67 sets the mlayout variable to our linear layout. 68 through 84 use the create storage controls method defined below that we'll look at in a minute to create the layout and set up listeners for the top row of buttons. Lines 85 through 100 do this for the middle row of buttons. 101 through 116 do it for the bottom row of buttons. Line 118 uses the start watching external storage method defined below to set up a broadcast receiver, and we'll look at this method in a minute. Line 121 through 125 use the onDestroy method to stop the broadcast receiver. 127 through 137 define the handle external storage state method that modifies the status of our external storage files. 128 through 130 set the status for the external public picture. 131 through 133 set the status for the external private picture, and 134 through 136 set the status for the external private file. Line 140 declares a broadcast receiver variable. 141 and 142 declare variables for storage status. 144 through 156 define the update external storage state method. 145 defines a string for the storage state using the Android getExternalStorageState method. Lines 146, 148, and 151 perform status tests. Lines 147, 149, 150, 152, 154, and 155 set storage availability and writability status based on these tests. Lines 158 through 171 define the start watching external storage method that sets up a broadcast receiver. Line 163 sets the update external storage state method to be invoked when the broadcast is received. 166 through 169 set up the parameters of the broadcast receiver to respond to media being mounted or removed. And you might want to review our lesson on broadcast receivers for more background on this. Line 170 updates the external storage state, and 173 through 174 define the stop watching external storage method that unregisters the broadcast receiver. And that's the end of our first of 2 lessons on external storage. Let's move on to part 2. This is the second of 2 lessons on accessing external storage from your Android apps. Part 1 dealt with a number of setup functions. In part 2, we'll see how external files are created and deleted. We'll continue examining the external storage API demo Java code. Line 179 through 221 define the create external storage public picture method. In lines 185 through 187, a file path is created where the picture will be placed. Line 191 creates a file directory. Line 198 creates an input stream using the getResources and openRawResource methods. Line 199 creates an output stream using the file, output stream class, and file name. Line 200 creates a byte array to hold the data using the available method that returns the number of bytes in the input stream. 201 reads the input stream into the byte array. 202 writes the output stream from the byte array. And 203 and 204 close the input and output data streams. Lines 208 through 215 use the media scanner connection scan file method to make the new file immediately available to the user. Media scanner connection provides a way for applications to pass a newly created or downloaded file to the media scanner service. The media scanner service will read metadata from the file and add the file to the media content provider. The media scanner connection client provides an interface for the media scanner service to return the URI for a newly scanned file to the client of the media scanner connection class. Lines 223 through 230 define the delete external storage public picture method that deletes the file. Lines 233 through 242 define the has external storage public picture method to create a directory path for that file. Lines 246 through 354 define the create, delete, and has methods for the other 2 files. Lines 358 through 375 define the create storage controls method that's used above to add text and buttons to our layout. Line 361 creates a layout inflator using the get system service method. Line 362 creates a new item object. Line 363 generates the view route. 364 and 365 set the descriptive text. Lines 366 through 369 set the path text if a directory path exists. Lines 370 through 373 create the 2 buttons, and line 374 returns the item. That's the second and last of our lessons on external storage. There's a lot of setup tasks involved in using external storage, but the core tasks of creating and deleting the files are not very complex. These lessons on external files should give you a good base for working with your files. This is the first of 2 lessons in which you'll learn how to use the SQLite database features of the Android system. SQLite is a subset of the SQL, or Structured Query Language, relational database system. SQLite is supported in the Android system in the Android Database SQLite package. The developer's website reference page for the package is shown here. In the training section of the developer's website, there's a good page on saving data in SQL databases. It covers the basics of creating and using an SQLite database. SQLite databases can also be used as part of an Android content provider component. And you may want to review our lessons on content providers as preparation for this lesson. We'll be using the same Notepad app we did in the content provider lessons in this lesson. We'll focus on the SQLite components of that app. So let's open it up in Eclipse and start it in the emulator. In Eclipse, in the Notepad source folder, we'll open the Notepad Provider Java file. And let's expand this out so we can see all the code. Lines 186 through 230 define our database helper class that extends the SQLite Open helper class. This class facilitates opening the database if it exists, creating it if it doesn't exist, and upgrading it as necessary. Lines 188 through 192 define the constructor for the class. Line 191 calls the superconstructor and provides our database name and version number. Lines 199 through 208 override the onCreate method for creating the database. Lines 201 through 207 use the execSQL method to create the database table. Lines 202 through 206 define the database column names and types. Lines 217 through 229 override the onUpgrade method, which upgrades the database from the old to new version. Lines 221 and 222 log a message that the database is being upgraded. Line 225 kills the existing table and existing data, and line 228 recreates the database with a new version. Line 243 creates a database helper object based on the class we defined above. At this point, if the database doesn't exist, it's created. However, it's not opened until its first access. So let's next look at accessing the database, and we'll look at how to query the database. Line 263 creates an SQLite Query Builder object. This is a convenience class that helps build database queries. 264 uses the setTables method to identify the database table we're using. Lines 269 through 297 choose the projection and adjust the where clause based on URI pattern matching. And for more background on projections and using URIs, see our lessons on content providers. Lines 300 through 307 set the sort order for the results. Line 310 opens the database in read mode. Lines 317 through 325 perform the query. And if we hover over query method and scroll down, we see a listing of the parameters. The first is the database that we're going to query on. The second is a list of which columns to return. Third is a filter declaring which rows to return. Fourth, selection args is the arguments to go along with our selection parameters, if these arguments exist. Next, the group by is a filter declaring how to group the rows. Having is a filter to declare which row groups to include. And sort order is how to sort the rows. Line 328 sets a notification to tell the cursor what URI to watch for changes. And 329 returns the result of the query in a cursor object. And see our lesson on content provider cursors for more information on cursors. That's the first of our two lessons on database. Let's move on to the second. This is the second of two lessons on SQLite database. In the first lesson, we looked at how to set up, open, and query an SQLite database. In this lesson, we'll look at code to insert, delete, and update data in a database. We'll be using the Notepad Content Provider app that was studied in our Content Provider lessons and that we used in the previous lesson. So I encourage you to review those content provider lessons as background to this lesson on database functions. I'll be focusing on the database code and won't explain the content provider code previously covered. Picking up in the Notepad Provider Java file, line 552 opens the database in write mode. Lines 555 through 561 perform the insert using the insert method. It returns a row ID of the new row created. If we, once again, hover over the insert method, we can pull up the list of parameters. The first is the name of the table we're going to insert the row into. The second one, called null column hack, provides the name of a column in which we're going to explicitly insert a null in the case where the values parameter is empty. And the values parameter is the map containing the initial column values for the row. The keys should be the column names and the values, the column values. And once again, see our content provider lessons for more information on value maps. Now let's look at the code to delete a row from our database table. Line 594 opens the database in write mode. Lines 605 through 608 perform the delete. Line 606 provides the database table name. 607 provides the where clause column names. 608 provides the where clause arguments. And I'll pull up the list of parameters if you want to pause and read these. So, for example, the column name might specify the column title, and the argument might specify the value John Doe. So the row with a title value of John Doe would be deleted. And finally, let's look at a database update function. Line 680 opens the database in write mode. 692 through 697 perform the update. 693 identifies the database table. 694 specifies the map of column names and values to be changed. 695 specifies the where clause column names. 696 specifies the where clause arguments. And I'll pull up the listing of the parameters if you'd like to look at them. That's our second and last lesson on SQLite database. If you combine the study of these two SQLite lessons with the group of lessons on content providers, you should have a good base for managing databases in your applications.